Okay, here we have another inverse Laplace transform, and notice that I know that I'm going to use a second translation theorem because I have an e to the negative s in my function, and that e to the negative s gives me a unit step function when I apply the inverse transform. Tells me I'm going to have a u to the t minus first multiplied by the inverse Laplace of 1 over s minus 2 times s plus 2 with that same shift. And so to find the inverse Laplace of 1 over s minus 2 s plus 2, I'm going to use partial fraction decomposition. And I'll set my fraction equal to a over s minus 2 plus b over s plus 2, and then multiplying through by the common denominator, I get 1 equals a times s plus 2 plus b times s minus 2. And here I want to distribute through by the a to get as plus 2a, and distribute through by the b to get bs minus 2b, and then combine my like terms. When I combine my s terms, I get a plus b s, and then my constant terms are 2a minus 2b. Okay. Now to solve for a and b, I want to equate the coefficients. For my constants, I get 2a minus 2b is equal to 1. And for my s terms, I get 0 because I don't have an s term on the left side. That should be equals 1. 0 is equal to a plus b. I can solve this system by multiplying the second equation through by 2 and then adding. The b terms will drop out, and I end up with 4a is equal to 1, or a is equal to 1/4. And then from this second equation, if I bring the a over to the other side, I get b is equal to negative a. So if a is 1/4, b is negative 1/4. So here the a is 1/4 and b is negative 1/4. And when I apply the inverse Laplace, I'm going to get 1/4 inverse Laplace of 1 over s minus 2 minus 1/4 inverse Laplace 1 over s plus 2. On this first inverse Laplace, the inverse Laplace of 1 over s minus 2 is going to give me e to the 2t. On this second inverse Laplace, 1 over s plus 2 is the same transform, but in this case a will be negative 2. S minus a negative 2, or s plus 2. So I'm going to get e to the negative 2t. Now when I bring this up here, for the inverse Laplace of e to the negative s over s minus 2s plus 1, I have that unit step function with this shift t minus 1. I'm going to multiply that by the inverse Laplace of 1 over s minus 2 times s plus 2 with that same shift. So my t's are going to shift so that they become t minus 1. I'm going to get 1/4 e to the 2 times t minus 1 minus 1/4 e to the negative 2 times t minus 1. And there's my answer.